Hello everyone. Yeah, welcome back to my YouTube channel, Akeem Ola. Still on variation. Today we are going to consider another type of variation. And the one we are going to consider today is joint variation. What is joint variation? From the name joint, it means a combination of two things together. So joint variation deals with the combination of direct variation and inverse variation. That is what joint variation is all about. So let's go solving the question on the board. We have here x, y, z are related quantities such that x varies directly as y. That means we are going to have solution. X varies directly. The varies we apply to the two of them. X varies directly as y and inversely as the square root of z. That means I'm going to have directly is always on a straight line. And remember, inversely always deal with 1 all over something. As in, for you to have inverse, there must be a fraction in which the numerator will always be 1 and the denominator will always be the letter you are given from the question. So we have here, the directly will be how? Y. All over the inversely will now be the square root of z. We have this. What we need to do, as we have been doing, change this proportionality sign into equality sign. By doing so, you are going to have our x now will now be equal to ky all over root z. Now we have this. Then we can now make use of the first information to get the value of our k. So from here, if we cross multiply here, we are going to have our ky, this one is z. We are going to have our ky to be equal to az. And we are looking for k. So our k now will now be equal to x root z all over y. And that will give us what is x. We have 300. From there, we can continue from here. We can continue from here. That means we are going to have our k now will now be equal to x, which is 300 times root z, that is root 25, all over y. What is y? 75. Root 25 is 5. So we have our k to be equal to 300 times 5 all over 75. Then we can now reduce to the lowest term. If you reduce to the lowest term, you will notice that 75 can go here. Let's go. 5 here is 1. 5 here is 1. That means that 2, that's 15. 15 here is 1. And 15 here is 2, 0. So our k now will now be equal to 20. So the relationship now, when we substitute k, the relationship will now be given by x is equal to 20 y all over root z. This is the relationship that we are going to use. This is the formula that we are going to use to solve any other question under this particular topic. They now said, now that we have gotten the relationship, they said, calculate the value of x when y is equal to 468 and z is equal to 144. Still using this relationship, we are looking for x. Our x now will now be 20 times y. What is our y? 468 all over the square root of 144. What is the square root of 144? The square root of 144 is 12. So we have our x now will now be 20 times 468 all over 12. Let's go. Reducing to the lowest term. What can go there? Can we start with 2? Let's start with 2. Or we can start with 4. 4 here is 5. 4 here is 3. Can 3 go in 4, 6, 8? Yes. 3 in 4 is 1. Mean that 1. In 16 is 5. Mean that 1. In 18 is 6. So our x now will now be 5 times 156, which will be equal to is 0. It means that 3. 25 plus 3, that's 28. It means that 2, that will now give us 7. So our x now will now be 780. As you can see, joint variation is a combination of direct variation and inverse variation. We have come to the end of the solution to this joint variation question. Next time, we are going to consider solving question on the last type of variation, which is partial variation. God bless you.